A cyclist freewheels with a constant acceleration in a straight line down a slope. As the cyclist moves 50 meters, his speed increases from 4 meters per second to 10 meters per second. Find the acceleration of the cyclist. Find the time that it takes the cyclist to travel this distance. The cyclist has a mass of 70 kilograms. Calculate the magnitude of the resultant force acting on the cyclist. The slope is inclined at an angle alpha to the horizontal. Find alpha if it is assumed that there is no resistance force acting on the cyclist. Find alpha if it is assumed that there is a constant resistance force of magnitude 30 newtons acting on the cyclist. Make a criticism of the assumption described in C part 2. Okay, that's the question then, a long question, but let's have a little look at it. I may write something in amongst the question as we go because of rather than drag it down the page and have to scroll up and down. So 50 meters constant acceleration from 4 to 10. Final velocity, initial velocity and distance. Find the acceleration. Well, that brings to mind v squared equals u squared plus 2as. So I'll put that in here. So this formula then gives, this is part A now. So 10 is the final velocity, so it's 10 squared is equal to, initial velocity is 4, plus 2a times the distance s, which is 50. So that's 100. I'll squeeze it in here, equals 16 plus 250s are 100. A. So what does that tell us then? Move the 16 over, 100 minus 16 is 84, is equal to, so I've moved the 16 over to minus 16. 100 take 16 is 84, equals 100a. And now read it down from right to left. 84 divided by 100, move the 100 from time to divide, is 0.84 ms minus 2. So there's the acceleration. I've squeezed it in here for part A, part 1, so we've got the acceleration. So I'll just summarize it here. A part 1, A is equal to 0.84 ms minus 2. Part 2 then. Find the time taken. Well, we know the other common formula is v equals u plus at, and we can use this one, can't we? So this formula gives, we know the final velocity, initial and the acceleration, so we can find the time. So 10 is equal to 4 plus 0.84 is the acceleration times the time. So move the 4 over, 10 minus 4 is 6, is 0.84 t, and then we can just now move the 0.84. 6 over 0.84 is equal to, tap it in the calculator then, 6 divided by 0.84, 50 over 7. And that's seconds. So there's the time for A part 2. So we've done that then. Okay, so we've done the time taken. Now part B. Cyclist has a mass of 70 kilograms. Calculate the resultant force. So part B. We want to apply F equals ma, don't we? F equals ma, this formula, gives, so the resultant force is equal to the mass, which we know is 70, times the acceleration, which is 0.84. So tap that in the calculator then. 70 times 0.84, 58.8 newtons. So there's B. So we've done the resultant force now, which is here. Now part C, the slope is inclined to alpha to the horizontal. Find alpha if there is no resistance force. Let's move on to C then, to find alpha. So we've got a slope. It's inclined at alpha to the horizontal, so we can put that in here. We can also put it in here, can't we? So here's our cyclist. It's got a mass of 70, so the force acting downwards due to gravity is mg. Okay, and this is the angle alpha in here, and this is a little right angle triangle. Difficult to see, I know, from the sketch being so small. So let's apply F equals ma in part C now. We'll apply F equals ma down the slope. There's no resistance. There's a normal reaction force, isn't there? But we're applying F equals ma perpendicular to this force. So 70g cos of the angle here, which is sine of the angle alpha. 70g sine alpha then is the force acting due to gravity in this direction. Component F, no resistance force, is equal to mass, which is 70, times the acceleration 0.84. So the 70s cancel. Sine alpha then is equal to 0.84. Move the g from times down to divide. So put that in the calculator and we'll get alpha. So shift sine, inverse sine, 0.84 divided by 9.8 equals 4.91 to 4.92, isn't it? And that's three significant figures. And there's alpha, 4.92 degrees. So there's alpha there. Now, it now says find the alpha if the resistance totals 30 newtons. Okay, so I'm just going to use the same sketch here and put in a little resistance force now of 30. So this was part 1. Part 2. So let's go down the same direction then, but this time we've got 70g sine alpha as the force due to gravity in this direction, minus the 30 is equal to the mass, which is 70, times the acceleration, which is 0.84, we're told, aren't we? Which is what we had up here. So we can work out sine alpha now. So 70g sine alpha. Move the 30 over. This is 58.8, isn't it? Because we worked it out before. Plus 30 is 88.8. So that tells us that sine alpha then is 88.8 over 70g. And now we do inverse sine to get the angle alpha. Okay, so inverse sine 88.8 divided by bracket 70 times 9.8. Close that bracket, close the inverse sine bracket. 7.437, so it's 7.44 degrees. So there's the angle value of the angle alpha if there's a resistance force of 30 newtons. Resistance acts against the direction of motion, so we were right to write what we did. Part D, made criticism of the assumption in C part 2. So D, as the cyclist's speed increases, the resistance, the air resistance for one increases, doesn't it? So the model inaccurately helps to spell it correctly. Inaccurately assumes constant resistance.